Okay, we are recording. So, let's tackle chapter 2.7. Double triangle problems. When more than one right triangle is involved, we need to decide which triangle to start with. So example 1 says calculate the length of side xy and round the final answer to 2 decimal places. So side xy is this side right here is what I'm looking for. So do I know anything else in that little triangle that's going to help me? And the answer is no. I know one angle. I don't know another side. So what is my strategy here? Well, I can find, I guess technically I know 2 angles. I know that's a right angle. I can find this side, let me use a different highlighter. I can find this side here because it's part of this triangle where I do know an angle and a side. So I'm going to find this angle here. I'm going to find YW. Actually, I guess I could call it side little z. I guess because I'm looking in the yellow triangle. So I'm going to find side little z first. And that's an opposite to this angle. That's a hypotenuse. Sine is opposite over hypotenuse. So the sine of 20 is the opposite over the hypotenuse. Now I'm going to cross multiply. So z is equal to 8.4 times the sine of 20. Now I'm going to punch buttons. First, I'm going to make sure I'm in degrees. I am. 8.4 times the sine of 20. And I get 2.87. Now, I'm not going to round that because that's not my answer. That's not really what I'm looking for. I'm looking for side xy, which I guess in this triangle I could call little w. So I'm looking for little side w. So I now know that's a hypotenuse in that little triangle. And this z, it was the opposite to the 20-degree angle, but it's the adjacent to this 22. So now it's a cosine problem. So the cosine of cosine of 22 is the adjacent, which I just found, 2.87 and a whole bunch of change, divided by this little w. So the first one was a multiply, this one's a divide. And again, I haven't yet erased that decimal, so I actually have it on my screen. So I'm not rounding anything. I'm just taking the number on my screen and saying divide by the cosine of 22. Oops, and I just mispunched 22. There we go. And I get 3.0, well, actually, it'd be 0.98. It wanted 2 decimal places, so I write 10. Okay, and that's in centimeters. And there we have it. I had to find this side to calculate that side. Question? Sorry, one more time? I can try. So again, let me just erase all my, that's not an eraser. There we go, there's my eraser. Okay, so once again, I am trying to find this line, right? X to Y. But in this purple triangle here, all I know is 2 angles. I don't know any sides. So I don't have enough information. But in this triangle here that I'll call this blue one here, in this triangle here, I know an angle and a side, so I can find how long this side is. Get it? Because this side's the same side in the 2 triangles. So that's what I did first. I found this blue side here from W to Y. I called it little z because it's across from angle Z. So I found that first. Now I have a triangle, again this purple triangle, where I know a side and an angle. So I use that to find my other side. And that's the other side I wanted was this side right here, right, X to Y, which I called little w since it's across from angle W. So that's how I solved it. I had to use one part to get the next. I used the blue triangle to get enough information to solve the purple triangle. All right, so that's example 1. Give you a sec to catch up to me. All right, 1 down, 4 to go. Example 2. All right, look at this guy. Determine the length of side x to z. Now, here's the thing about xz. Xz is not an entire length in this right triangle. It's only from there to there. So that's what I'm looking for. That's the side I want. So I'm going to need some sort of strategy for this. The strategy I'm going to use is, if I could find xz here is really x to u minus z to u. In other words, if I can find this entire length from here to here, and then minus the length from there to there, that would be the leftover little part. So it's going to be a subtract. So I need to find x to u and z to u. It might even be helpful if I redrew the two triangles so that they're not one on top of the other. So this will be the big triangle, from x to u to y. How big is this angle at y? You might be going, well, isn't it 24? No, 24 only gets me from there to there, and then it's 6 more from there to there, so this is 30 degrees. And then I have this littler triangle. I'm kind of exaggerating how much smaller it is, but you get the idea. Where this is 24 degrees. This is still y. This is still u, but instead of point x, I'm only up to here at point z. All right, now what do these two triangles have in common? They both have a base here of 133 centimeters. So I am going to have to find x to u, which I think I'll call that little y, because it's across from y. And then I have to find z to u, which is also, in this case, little y. So I'm going to solve for those two things. I'm going to solve for the y in this triangle and the y in that triangle, then I'm going to subtract them. And that would be the line I'm looking for. So that's an opposite. That's an adjacent. This is a tan problem. Tangent of 30 degrees is equal to opposite over adjacent. So that little angle I'm looking for there, or that little side I'm looking for, is 133 times the tangent of 30. Okay, I punch buttons. What do I get? 133 times tangent 30. 76.78? 79, I guess, but I'm not rounding yet. That's not my final answer. So that's this triangle dealt with. Now let's deal with this triangle. The triangle on my right, tangent of 24 is equal to y over 133. It's going to be a little smaller because 24 is smaller than 30. So 133, 133 times tan 24 is 59.215 blah, blah, blah. And my final answer then for x to z is to subtract them. So 76.78 blah, blah, minus 59.21 blah, blah. So I'm going to actually subtract that. So let's see. So I'm going to go 76.787 minus my answer that I had, and I get 17.57. I wanted 2 decimal places. And what unit are we in? Centimeters. Okay, any questions on how I did that one? Let me move back so you can see the whole thing there. Okay, oh, okay, hers than you. Yeah? Because it tells me in the diagram that I'm given that it even gives you a little, did I make those lines? Yeah, I did, sorry. It tells you that in this diagram that from here to here is 24. So when I redraw this triangle here, I'll highlight it in green. Can you see the green? No. I'll use a bigger thing then. I'll use a highlighter. Green. There we go. Green. There we go. There. I'll color it. There we go. That triangle there is over here. Right? Okay, so there's that one. Okay, now let me get rid of the green. Then, let me use a different color. Let me use blue. this blue here, this triangle, is right here. Right? So how did I get the 30? Because it's the whole angle from there to there. Usually when I do a problem like this, and maybe this was your question coming up, why didn't you use just, hang on, let me get rid of the blue. Why didn't you just use this triangle here? Why didn't I just use this one? It's a triangle.
Yeah, but it's not the, what's the word, right angle.
Yeah, that's the problem. The way it stands right now, I only can use SOHCAHTOA on right-angled triangles. In grade 11, that's going to change. In grade 11, you'll learn how to do sine, cos, there's no tangent, but sine and cosine on triangles that don't have right angles in them. But that's a grade 11 topic, not grade 10.
Let's just stick to the simple stuff for now.
For now, I think you're probably going to be happier with this.
Our brains
Okay.
are already a little...
Did that answer your question too? Yeah, where'd the 30 come from? Yeah, okay. We're good? All right, example 3. Okay, guys at home, if you have any questions, you can, I've got the chat going here so I can see you. All right, this is a classic. So I would like to determine the measure of angle QRS. So I would like to know this angle here, Q to R to S. Right? When they use three letters like that, you basically just play a little connect the dots game. Go from Q to R to S. The middle was the angle you were looking for. Okay? So now, if I'm looking for that angle, I'll put a little question mark on it. Once again, I need to know at least 2 sides to find an angle. And I only know one. I know the 370. So what I can do is I can use the triangle on the left, and I can find this line here, because it's part of this left triangle. So let's see, what can I do to find it? If I am looking for this side, I guess I'll call it side little p. What do I know about it? It is a hypotenuse, and this is an adjacent. Which one's adjacent to hypotenuse? Cosine. So the cosine of 55 degrees is the adjacent over the hypotenuse. D for denominator, D for divide. You too. See you later. Okay, so let's find side P. 180 divide, oops, oh, I hit the wrong button. 180 divided by the cosine of 55. There we go. 313.82. Again, I'm not going to round it because I'm going to use it again in a minute. And now, this was a hypotenuse in the yellow triangle, but now I'm in a different triangle. Now I'm in this green triangle. And in the green triangle, the hypotenuse is the 370. What's the side that I just found in that triangle? It's an opposite. It's an opposite to the angle R, right? So I have an opposite hypotenuse calculation. Which one's that? So the sine of angle R, which is the one I'm looking for, is the opposite side, which is the thing I just found. There's no way to avoid using the thing you just calculated, divided by the hypotenuse. So my angle R is the inverse sine of that divide. And now I punch buttons. And again, I don't have to repunch that decimal because it's still sitting here on the screen. If I had made a mistake and accidentally erased it, I do have an answer button. And most of you have an answer button on your calculator. It always remembers the last answer you did if you have an answer button. Okay, so the inverse sine of, open a bracket, my answer, I'm going to use my answer button, divided by 370. And then I close my brackets and hit equals, and I get 58 point, let's see, what do we round around to? 2 decimal places, so 0.1 degrees. Okay? Yeah.
I copy and pasted mine.
Well, if you copy and pasted it, we should have exactly the same answer because I used the answer button, which does the same thing, a copy paste. So let me try it here. 180 divided by cos 55, and there's that number. And then take that number, so I go inverse sine of open a bracket, paste that answer, and divide by 370. And 58.01245. 885, yep, that's it. And again, we only needed 2 decimal places, so that's plenty accurate.
I could give him 30. I could give him 30.
But by the time you'd be that many decimal places, I mean centimeters, you think about how small that would be? You're accurate, you'd be accurate to the nearest like electron orbital or something. Okay, so anyway, 2 more.
So then why do we even bother going?
Is it going too fast? Okay, question from the back of the room. Yep. Okay, I can't, a little louder? How did I do go back to example 2? Okay. How about I'll put it back up after so that we can keep going here, okay? I'll go, remind me at the end and I'll scroll back to example 2. Okay, another question. Well, again, hold up your calculator. Show me what kind of calculator you're using. Yeah, if you look on your equals button on the bottom right, in green letters it says ANS. And it's the fact that it's in green means to access it, you have to hit that alpha button up in the top left area there. So turn your calculator off even. Go make a sandwich, whatever. It doesn't matter. It remembers the last answer you got. So if you hit alpha and then the equal sign, and then just hit equals, it'll be that last answer you just got. So that's what I'm doing. When I say I cut and paste, I'm just using my answer feature. The cheaper calculators don't have that. So if I was using one of these guys, and I'm holding up, I don't know if you can, well, yeah, guys on the video can't see this, but guys at home can. If you had one of these kind of calculators, or the cheaper model of this Sharp that doesn't have an answer button, you still have memory features. If you absolutely needed the accuracy, you could store a number into memory and then recall memory. I can show you how that works if you want, but
I'm picking up a new calculator this week, and right now I have to use my phone's calculator.
Yeah, on the test you can't use your phone. Yeah. Phones do, really at the end of the day, it's just that I don't want you having a communication device on a test. Smartphones have great calculators. You turn your smartphone to the side and you get a really nice scientific calculator.
Small green line, you press that.
Yeah, it depends on what version of calculator you're using.
My calculator has arrow buttons and stores the last 18 answers.
Very nice. All right, we're going to go a couple more. These two have like word problems on them, right? They've got context. So a surveyor stands at a window on the 9th floor of an office tower. He measures oh good, we're going to use these ideas that we learned first lesson of the unit. The angle of elevation and the angle of depression. So he stands here, he measures up from a horizontal line 31 degrees, that's his angle of elevation. He measures down from a horizontal line 42 degrees, that's the angle of depression. And then he would like to know the height of this building. So the height of the building is of course going to be the distance from B all the way to T. So that's what we're looking for. We know some of it. We know from the floor to M is 39. So really what we need to find is we need to find this little angle here, which I guess we could call little s. It's across from s. You could just call it TM if you wanted. So I would like to find the distance from here to here. But, problem, I only know one fact, well, two I guess, right angle. I don't know any sides. Sorry, one more time?
Is that a perfect square?
We don't know that. The question, in case you couldn't hear it at home, was can I assume this is 39 because that bottom thing does kind of look like a square, but it doesn't tell you that it is and you can't assume that it is. So you're going to have to use some trig. So we're going to use trig to find this line here. I guess I could call it line B. I guess I could turn on the pen.
Yeah.
I could call that line B. And line B is an adjacent, 39 is an opposite. So the tangent of 42 is opposite over adjacent. Okay, we're going to get fancy on this one. Angle side B, right? D for denominator, D for divide. And I'm not going to bother punching that in. You can if you want, but I'm not going to bother because that's not the answer I want. The answer I want is this side here. So let's make a trig equation for that. It's tangent again. The tangent of 31 is the opposite side, which I called little s, over the adjacent side b. And to solve for little s, I'm going to move down so I have more room. Little s, right, t for top, t for times, is b times the tangent of 31. And then, oh yeah, instead of b, I'm going to replace b with that. So I'm actually just going to do this, all this button punching at once. Why? What's the difference between this being a divide and this being some big ugly decimal? It's the same thing. It's just a number. It's a complicated looking number, but it's still just a number. So there we go. I'm going to just punch it all at once, just for fun. So 39 divided by the tangent of 42 times the tangent of 31. And there we go. Now, if I stop there, okay, how many places did we want, by the way? Nearest tenth, so we only want one decimal this time. 26.0 meters. If we stop there, we're going to lose at least half a mark. What did the question actually want? The whole height of the building. All I figured out is the distance from here to here. So therefore, height of building is equal to 26.0 plus 39. So just add 39 to my answer. And it's a 65 meter tall building. That's true. I should show the person looking at my work that I did indeed round it where they told me to. So even though that 0 has no value, it still has meaning. It still tells you where you rounded. Yeah, very good. Pretend we're in science and it's a sig fig question.
You could have just popped the whole thing and you could just add, you could have done it in like one equation.
Yep.
It's 39 over tan 42 times tan 31 plus 39.
That's right. I could have done that too.
Wow.
I love variables. This is exactly
Okay.
what I love.
Okay, good. You'll have fun when we do systems of equations. All right, one more. The sign for a restaurant is mounted on a pole from a position 5 meters from the base of the pole. So we're saying that this distance from here to here is 5 meters. We're going to assume the guys who put up the pole knew what they were doing, and it's a right angle. And Mike has to look up 42 degrees. Now, what do we mean by look up? We mean look up from some imaginary horizontal horizon line. So he has to look 42 to see the bottom of the sign. So from here to here is a 42 degree angle. Then he has to look up 52 to see the top of the sign. So to see the top of the sign, I don't like that line, it looks curvy. See the top of the sign, he has to look up at a 52 degree angle. So how tall is the sign? Well, I'm going to make two triangles out of this. Okay? This is very, very similar to one of the other ones we did. I'm going to make two triangles out of this. I'm going to make a small triangle. I'll use blue for that one. So this blue triangle here.
Are we trying to figure out the height of the sign plus the pole?
Just the sign. Notice it even kind of, see the symbol there? Right? Okay, so I'm going to find, so I have this triangle here, which I'll draw in blue, which is, that's 42 degrees. And we'll call this, I don't know what we'll call this. We'll call this maybe, call this X, I guess, if you like. And what do we know in this triangle besides the 42 degrees? Oh yeah, it's 5 meters across the bottom. And then I'll make a green triangle that goes up to the top of the sign, down to where his eyeballs are horizontal to the bottom. And I'll draw that triangle down here. And this is still 5 meters, but this angle here is 52. And I don't know, we can call this one Y if you like. So what am I actually looking for? I'm looking for Y minus X. The green line minus the blue line should be how tall the sign is. And yes, these are both tans. Correct. Question? Well, no, because he looks up. Look at the way that this one works. He looks up 42 degrees to get to here, and he looks up 52 degrees to get to here. Right? So they are two separate angles. I'm not looking for some angle that's those two things put together, which is a good thing because that'd be a 94-degree angle. He'd be looking back over his head and the other way. So that'd be tough. He'd have hurt his neck trying to look at that angle. 52 is the entire green angle here, up to the top of the sign.
There's only two green lines.
That's right. Well, I'm sorry. If there are people who have a hard time seeing color, let me know. I can always make sure that I label them differently or something. Okay, anyway, I think these are both tans, aren't they?
Yes.
So the tangent of 42 is x over 5. So x is equal to 5 times the tangent of 42. And you know what? I'll leave it up to you. If you're happy doing it the way I do it, and I like to punch buttons once, but if you want, you can get that answer and keep the decimal. But I prefer to just punch buttons once. The tangent of 52 in this triangle is y over 5. So y is equal to 5 times the tan of 52. So my answer is y minus x. And in my work here, y is 5 times the tan of 52. And x is 5 times the tan of 42. And you know, if you want to use the knowledge we learned from last unit, we could even make the button punching easier. We could factor out the 5. And use our brackets on our calculator. So I think that's what I'm going to do.
Could you make that tan 10? Just 5?
That's an excellent question. Isn't this like saying, you know, like 5x minus 3x is 2x? No, it's not. I can't consider these like terms. They are not. Because tangent's not a thing, right? Tangent's not a number. It's an operation. So can I point out what is tangent? Tangent is a ratio, right? It's the opposite over the adjacent. But here, I'm going to ask you a question. You're thinking, for those of you maybe, again, I keep forgetting that maybe the people at home didn't hear the question. It's a great question. The question is, if I'm simplifying it to try to cut down on how many buttons to punch, which is a good thing for me, the mistake I'm going to make is I'm going to be clumsy punching buttons. So the simpler I can make it on the page, the less buttons I got to punch. So think about this. I did that factoring, so I got less buttons to punch. Now, why can't I just say that's the tangent of 10? It isn't. Because, again, tangent's not an operation that I can do that with. If you had something like, say, 3x minus x, you'd say, yeah, that's 2x. But tangent's not a thing that you times by. It's not a number. How about this? Could you say that the square root of 25 minus the square root of 4 is equal to the square root of 21? Is that a true statement? No, it's not. Because, you know, that's 5 minus 2 is 3, and square root of 21 is nowhere near 3. So no.
Way to do tan and cosine and all that by like not using your calculator?
Yes, certainly people who are just slightly older than me. When I was in grade, I didn't see this stuff till grade 10. No, yeah, grade 10. When I was in grade 10, we had to buy a scientific calculator, and really, I think about 2 years before I was in grade 10, they weren't making students buy scientific calculators. You did this stuff by looking it up in a booklet. So you'd look up in a booklet how big the tangent of 52 was, and you'd write down the decimal.
That booklet.
Yeah,
How
so
did
that's...
the booklet get it then?
Then there is another way to do it, and they didn't even try to teach this to you until you got to grade 12. Maybe you've heard of this thing. It's called a slide rule. Maybe you've seen one in your grandparents' garage or something. It's a ruler that has 3 pieces. The middle part slides back and forth between the top and bottom. And you can use that to figure out sines, cosines, and tangents of angles up to 90 degrees. So my dad had one, and he tried to teach me how to use it once. I never quite figured it out. It's nowhere near as easy as this. Actually, I was even pretty good with the booklet if I had to look it up in the booklet. Okay, anyway, I punch buttons now. So 5 times, open a bracket, tan 52 minus tan 42, close brackets, hit equals, and there we go. The sign is 1 point, how many decimals did we want? Nearest meter. So I'll just write this down since I started it. 2 meters. It's a 2 meter tall sign. So there we go. You can now try the questions that I'm assigning. I'm not assigning all of the 2.7 questions. I picked some good ones. Okay, I'm going to stop the video. Give me a sec to stop the video here.